Okay, these last two sections. First 10.7, special segments in a circle. You can see a lot of connection relationships between segments interior and exterior of a circle. A chord segment is segments that are formed when two chords intersect inside a circle. We'll see that. These are chord segments. The little red guy, the blue guy, the purple guy, and the green guy. These are chords. These are chords. These are chord segments. These are the things that are created when two chords intersect inside a circle. It says if two chords intersect inside a circle, then the products of the lengths of the chord segments are equal. And this is, there's a blocking point for some students here, so be careful here with what this is. So what we're saying is if this is 3 and this is 8 and this is 4, then this has to be 6. Because the product has to be equal to the product. That's what this says. So if this is 3 and 8, the product is 24, and the product here has to be 24. So if I know that's 4, then that has to be 6. Now, please understand, the length of the segment is 11, and the length of this segment is 10. Nobody's suggesting that the segments or the chords are congruent. Nobody's suggesting that. We're just saying that the product of the chord segments have to have the same product. So it works really nicely here because these have a product of 108. So these have to have a product of 108. So you get 8x equal 108. You divide by 8 and you find out 13.5. A little more difficult algebraically. We're saying the product of these two equal the product of these two. The product of these two would be x plus 4 times x plus 2. I heard that all the way from here to there. And the other one, these two have to have the same product as these two, so that's the equation. So we have to FOIL that. I'm going to kind of cheat and go ahead and put the O and the I together. Distribute that. I can see that the x squares cancel. And so probably bring this over here. 8 is equal to 4x. X is equal to 2. What they asked me to find? The x. Done. Now if I want to check it, I go back and I say, well then that's 12 and that's 2 and that's 6 and that's 8. Product, 24. Oops, messed that up, didn't I? That's a 4 right there. Put the 2 in. Product, 24, product, 24. X is 2. And so this is just more of the same. You can see how that 5 times x has got to be equal to 80. So x is 16. There it is. And we could do some more algebra with this one. It's the same as the last example we did. So I want to do this problem, this nice little problem. Biologists often examine organisms under microscopes. The circle represents the field of view under the microscope with a diameter of 2 millimeters. Okay, the diameter is 2 millimeters. Determine the length of the organisms if it is located 0.25 millimeters from the bottom of the field of view, round to the nearest hundredth. So they tell us that this is 0.25 millimeters up to here, which means if you could come in here and pop the center, remember the diameter's 2, so the radius is 1, like from here to here would be 1 millimeter. So from here to here would be 0.75. Because then this is 0.25, makes the whole 1, the whole 1 makes the whole 2. Okay? Got it? With me? I want to know what that is. So remember in a previous lesson where without any warning, it just was like really, really useful to us to draw in a radius, which happens to be 1. And what that does is create a beautiful situation here where we have a right triangle. Because we have a right triangle, we can find the length of this leg, knowing the other leg and the hypotenuse. So c squared is equal to a squared plus b squared. So we put the c squared in there. 1 squared is 1. That was nice and easy. 0.75 squared plus some unknown b squared. Then it would be a matter of solving that with the calculator and all the, stuff that goes with that. You can see they did same thing here. They ended up, squaring. They got 0.66. Oh, they did completely different than I did. They said the product of these two has to be equal to the product of those two. Hey, I guess that's the section we're in. Makes sense. Says the Phil is installing a new window in addition for a client's home. The window is a rectangle with an arched top called an eyebrow. The diagram below shows the dimensions of the window. What is the radius of the circle containing the arc of if the eyebrow portion of the window is not semicircle? So we're not saying this is semicircle. We're saying it's part of, though, a circle that goes on, and they want to know what the radius of that circle is. How do you draw that arc if you don't know what the radius of the circle is? So how do you get that look if you don't know how to deal with these other dimensions? So I've got next page here because we're going to look at it on the next page. We want to know the radius of that circle. So here we have the general idea of our problem. Here's our rectangular window with our eyebrow window above, right? And we've been told that this is 12 feet and this is 2 feet. So this is 12 feet. This is 2 feet. So this is 6 feet, and this is 6 feet, and this is 2 feet. Okay, and the question is, what's the radius of the circle? So what's the diameter, what's the radius? That's what we want to know. 2 feet, or 6 feet. So if I let this unknown piece here be x, and that's 2, and what I know is that 2 times x has to be equal to 6 times 6. The product of those two chord segments has to be equal to the product of those two chord segments. Because when you have two chords intersecting in a circle, that's how that works. So then 2x is equal to 36, x is equal to 18, right? Which means the diameter is 20, because you had the 18 plus the 2, which means the radius is 10. Going back and looking, that's answer A. Answer A. All right, so earlier, I guess in the previous lesson, we looked at the relationship between the exterior angle and its intercepted arcs. Remember, it was half the difference. Half the difference. In this case, we're not looking at the measure of the angle, we're looking at the measures of the segments. So it says if two secants, and these are secants, they're not tangents, two secants intersect in the exterior circle, they have a common exterior point, then the product of the measures of one secant segment and its external segment is equal to the product of the measures of the other secant and its external segment. Now, that's really, really wordy, really wordy. What they've got here is that AC, the whole thing, times AB, the outside piece, is equal to AE, which is the whole thing, times AD, which is the outside piece. A few years ago, a couple classes we were working with, one of them decided the way they wanted to see this is whoa. Whole thing times outside piece equal whole thing times outside piece. That's exactly what this is. Whole thing, outside piece, whole thing, outside piece. And the beautiful part about this is it works for secants and tangents, or a mixture of secants and tangents. So WOA, instead of trying to remember all these words and how that fits, the whole thing times the outside piece equals the whole thing times the outside piece. So let's look at that in practical form. So I've got it written here. Actually, I've got it written backwards. I've got outside times whole thing. That's ow. I like whoa better. Whoa. Okay. So they want us to find x. So if we're talking about this one, whole thing is x plus 8. Right? Outside piece is 8. And then if we're looking at this one, whole thing is 34. Outside piece is 10. Whole thing times outside piece. Whoa. So here 8x plus 64 is equal to 340. 8x is equal to 276, I believe. And x is equal to 30 something. Did that right? Subtract 30 something. 30, that's why I could get it to come out as a decimal. 34.5. Well, they got the same thing we had, 8x equals 276. So whole thing times outside piece equal whole thing times outside piece. Whole thing is x plus 24. Outside piece is x. Whole thing is 52. Outside piece is 25. So x squared plus 24x is equal to, let me pop that in the calculator, 52 times 25. 52 times 25. It's 1,300. Nice. 1,300. Now, this is one of those things that happens to us in geometry. We're driving along, we're minding our own business, we're trying to learn this geometry stuff, and they throw crazy algebra at us. And what that is a quadratic equation that we're going to have to solve. We learned how to solve quadratic equations in geometry. We either factor and use zero product property. We can graph sometimes. We do have completing the square that we did. We have the quadratic formula. But somehow we're going to have to solve this quadratic. Now in this case, I'm going to drag the 1,300 over here and set it equal to 0. Because in most of the different things I just mentioned, you would want to do that. The only one you wouldn't would be probably completing the square. And so what I'm looking for here is factors of 1,300 whose difference is 24. And so then, I'd be able to factor. I know this is double bubble, x and x, signs are different. I mean, there's no GCF, it's not a special case. So it ends up being a leading coefficient 1, so it's that. So I'm looking for factors of 1,300. And that's going to be some work, factors of 1,300. Because you got 1 in 1,300. You got 2 in 650. Believe it or not, I don't think 3 works. Nope, it doesn't. And 1,300 divided by 4. So 4 and 325. 5 would obviously work. 260, I believe. And if 3 don't work, then 6 doesn't work, and 7 doesn't work, and 8 probably works. And obviously it's a lot easier if you got a calculator. 8 did not work. 9 doesn't work because 3 didn't work. 10 definitely works, so 10 and 130. 11 doesn't work. 12 doesn't work because 3 didn't work, so it's 3 and 12. 13 does work. That's an obvious one. 14 doesn't work because 7 didn't work. 15 doesn't work because 3 didn't work. 16, I'm thinking it doesn't work either. So maybe there'll be an easier way. 16 doesn't work. 17, 18 doesn't work. It's 20, 1,300 divided by 20. 20 and 65. I'm stretching myself out here a pretty long way. We know the 25 worked, that's where it came from, the 25 and the 52. I'm looking for a difference of 24. Doesn't work either, does it? But I am in the neighborhood. So I'm gonna try 1,300 divided by 26. I get 26 and 50, and that's my 2, right? And so in order to be positive, it had to be this way. So x is either a negative 50, no it's not, you can't have that be negative. So no it's not, nope. Or x is 26, and that's the one that works. And what I would do, if I was doing this, I'd come back and put 26 right there, and then I'd multiply whole thing, which is 50, times outside piece, whole thing, which is 52, times outside piece, and confirm that it worked. That was a lot of work, kind of painful, but you gotta do something, and you gotta know your algebra. If you're gonna go to take pre-calculus, you better know that algebra and a lot more. So have to work your way through it. Okay, so in this case, we have a secant and a tangent. Now the beautiful part about the WOWO is that it just works. It just works. WOWO is like the whole thing times the outside piece. It's so happening, and they give you this formula here, they give you these words here, but look, here's how this works. The whole thing times the outside piece. That would be JK times JK, which is JK squared. Or JK times JK. Whole thing times the outside piece. Equal whole thing, it works. So for us in this particular problem, whole thing is 2x plus 2. Outside piece is x. Whole thing is 12 times outside piece, which is 12. So I'm going to get 2x squared plus 2x equal 144. So 2x squared plus 2x minus 144 equals 0. Okay, so that's what I got to solve. I'm going to go ahead and divide by 2. I'm going to get x squared minus x, or plus x, minus 72 equals 0. And that's going to be an actually easy factoring, because factors of 72's difference is 1, it'd be 8 and 9. So double bubble, x and x, signs are different. It'd be 8 and 9, it'd be 8, it'd be 9 minus 8 to give me the positive 1. So that's how I know who's who. So x is either negative 9 or positive 8. The negative can't be true because you can't have a negative out here. You just can't do it. You can't have a length that's negative. So that is excluded. And it leaves me with 8. So this is 8, so this is 8, and this is 10. So the whole thing is 18 times the outside piece is equal to 144. You can check and see that it works. Nice. And it's just practicing the stuff we just did. In fact, that one's going to be easier than the one we just did, because the whole thing times the outside piece equal the whole thing times the outside piece. So the x squared is equal to 900, I believe. So x is equal to 30. That was a lot easier than the last one, but you can see how that would work, and it is in fact 30. And that's it.